Introduction to neural networks. So, sorry. So we're gonna start with what are neural networks. Basically, neural networks are computer systems inspired by human brains. Just like our brain has billions of neurons connected by synapses. In AI, we build artificial neurons connected by weights. These artificial neurons receive input, then process it and passes information to the next neurons. So the whole concept basically it's the inspiration from the human brain, just like human brain the neural networks work. Like biological neurons take input signals through dendrites, then process it and sends output via axon. And in artificial neuron like human made, it take input just like numbers, then multiple with weights, add bias and apply activation function and give us the output results. So this is how artificial neurons work. So we are mathematically just mimicking how the brain works. So the whole process is just a mimicking of the human brain. Now the question is why neural networks? Some there's some um, there's some logic behind why we need neural networks. Like traditional programming, we give rules plus data, then computer give us output. Like what happened in programming language, for example JavaScript or Python, we give there's some set rules and we give some statement and computer give us output. In machine learning, we give data plus output and computer learns the rule. And in deep learning, neural networks, computer learns rules directly from raw data using multiple layers of neurons. So this is a process of learning. So we have to feed data and the system will learn through the data. So computer learns rule directly from the raw data using multiple layers of neurons. Example, traditional to recognize cats, you must write rules, right? Like for example, just imagine that this is a cat, this is not dog. How you differentiate his ear shape, whiskers or tails? And in neural networks, just feed thousands of cats and dog images, and it learns the features automatically. So we have to feed data to the system, then the system automatically will generate idea through the based on that data. So this is about why neural networks. Now real world use case. So if we talk about real world use cases like image recognition, this is very much a common example of neural networks. Face unlock in phones, we have to feed data first, right? Our like it could be our fingerprint, or sometimes it could be the eye blink. So this is kind of invention of neural networks. And natural language processing NLP like Google Translate, ChatGPT itself is the product of neural networks. Robotics, self-driving cars, healthcare, cancer detection from X-rays, and finance, fraud detection, stock predictions. And if I talk about structure of neural network, so there is input layer which take raw data. Just example, pixel of an image. Pixel is like a square, right? So each of the pixel is kind of take the raw data, which is input layer. Then hidden layer process the data through mathematical operation. More layers, deeper network, more learning capacity. So this is the hidden layers process the data through mathematical operation. And output layer give the final prediction that when we give hundreds of images, then it's process itself and give up the output, whether it's cats or dog image. Just for an example, I give you an example. And there's a mathematical recognition, mathematical representation of neuron. Each neuron does just for example, there's a equation, mathematical equation, y equal f of summation I equal 1 to n wi xi plus b, where xi is input value, wi is weights, b is bias, extra flexibility, and f is activational function. So if you give the value, just the example input, if I give it input 2 and 3 and weights 0, 5 and 0, 4 and bias equal to 1, then activation equal to sigmoid, then output will be very close to 1. You can do the whole calculation. And lastly, the activity. Just imagine that there is three layers of in a neural networks: input, hidden, and output. If I give a real world example, then similarly, like when you see a cat, how does your brain know it's not a dog? What feature do you use to differentiate? Maybe his ears, eyes, or the size. The same in neural networks. So automatically learning important. So it's automatically learn. We have to feed him data. Then based on this data, he will generate important features. So automatically learning system. So it's all about the introduction. I'll see you in the next lecture. If you like this content, please like, share, and subscribe the channel. It's really help to grow the community. Thank you.